Okay, now we're going to talk about scientific notation. This is 4.2. Okay, so scientific notation is taking a number. Okay, and I'm gonna so you have like, say that's the first number, dot, and then there's going to be other things after it, other numbers after it, right? Times 10 to some value. Okay. But the only thing we put before it is one number. Okay. So one number only goes before it. So when m is positive, okay, we move the decimal to the right to get the original number. And when m is negative, we move the decimal to the left to get the original. Okay. So here we go. Express 8500 scientific notation. So again, scientific notation, you can only have one number in front of the decimal. Now you're probably like, so where is the original decimal? So in the number 8500, the decimal is originally where the number stops. Okay. So to write it in scientific notation, we get the decimal to where we only have one number in front of it. So 1, 2, 3. So this is going to be 8.500 times 10 to the now. We moved it left to get it into scientific notation. But in order to get it back to our original number, we would have to make it right. So this is going to have to be a positive number. So to the third. Okay? All right. Here we go. 820,000. The original decimal is here. 1, 2, 3, 4, 5. 8.2. Now, if you have a bunch of zeros after, you don't have to keep them. Times 10 to the 1, 2, 3, 4, 5. So it's going to be a positive 5 because in order to get the original number, we'd have to move it back to the right. Okay? All right. Again, original decimal 1, 2, 3, 4, 5, 6, 7, 8, 9. So 7.56 times 10 to the 9th. Okay, now we're doing decimal numbers. So these are going to have negative exponents. So here we go. We have where the decimal starts is just where it is now. We actually have a decimal. So 1, 2, 3, 4, 5, 6, 7 gets us one number in front of the decimal point. The original number is negative, so negative 2.45 times 10 to the negative 7th. Okay, let's do it again. Decimal point 1, 2, 3, 1, 2, 3, 4, 5, 6, 7.2 times 10 to the negative 6. Okay. This should not have an extra decimal there. So here we go. 1, 2, 3, 4. So negative 4.62 times 10 to the negative 4th. Now we're going to do standard. So we have 10 to the 7th. So we're going to move it to the right. So 1, 2, 3, 4, 5, 6, 7. So that gives us our original number. Negative 3. So we're going to move it to the left. So 1, 2, 3. So that gives our original number. So I usually like put the decimal, count zeros, and then this is like the last number. All right. To the 10th. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. To the 0. Remember, anything to 0 is 1, so we're just multiplying by itself. So that it's just itself. All right, so we can use standard or scientific notation in order to evaluate, and it helps us. We can use exponent rules. Okay, so first let's change these all to scientific notation. So this first one would be 1, 2, 3, 4, 5, 6. So 1.92 times 10 to the 6 times 1.5 times 10 to the negative 3 over 1, 2, 3, 4, 5. 3.2 times 10 to the negative 5 times 4.5 times 10 to the 1, 1, 2, 1, 2, 3, 4. Okay, now when we do this, we're going to multiply our numbers, like the coefficient numbers, so like 1.92 and 1.5, and I get 2.88 times 10 to the, now when we multiply like bases, we add, but that would be subtracting because 1's negative, so 10 to the third over, then I get 3.2 times 4.5, 14.4, add, times 10 to the negative 1. Now I'm dividing. So now I'm going to do 2.88 divided by 14.4. That gives me 0.2 times 10 to the 3 minus negative 1 is 4. So that's my scientific notation number. And then if I want, actually that's not my scientific notation number because this number would need to be up front. So it's actually 2 times 10 to the third. That's the scientific notation number. And so the final answer is 1, 2, 1, 2, 3, 2000. Okay? All right, let's do another one. So 1, 2, 3, 4. So 6.3 times 10 to the negative 4 times 1, 2, 3, 4, 5. 4 times 10 to the 5th. 1, 2, 3. 1.4 times 10 to the 3rd times 1, 2, 3, 4, 5, 6. 3 times 10 to the negative 6th. Okay, so we're going to do 6.3 times 4. That gives me 25.2 times 10 to the 1st. Then 1.4 times 3 gives me 4.2 times 10 to the negative 3. Then 25.2 divided by 4.2 gives me 6 times 10 to the negative 2. That's my scientific notation. So move the decimal point, remember to be here. So 1, 1, and then 2. So 0.06 is the answer. Okay? Those are the answers. All right. The speed of light is approximately that centimeters per second. How long would it take to travel 1.2 times 10 to the 15 centimeters? So remember, distance equals rate times time. So this would be our rate, this would be our distance, and we're solving for time, so time equals distance over rate. So we're going to do 1.2 times 10 to the 15 divided by, and we want to change this to scientific notation. So the scientific notation would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 3 times 10 to the 10th. So 1.2 divided by 3 gives me 0.4 times 10 to the 5th, but that's not the scientific notation. So it's actually going to be 4 times 10 to the 4th. And then, so that's the scientific notation answer. And then our actual answer is 1, 2, 3, 4. So 40,000 seconds. Okay. All right, so the last one. In 1990, national healthcare expenditures in the United States were $724 billion. By 2012, healthcare expenditures were 4 times this amount. Write the amount of healthcare expenditures in 1990 using scientific notation. So 1990 would be 7.24 times 10 to the second. And then to get the healthcare expenditures in 2012, we take 7.24 times 10 to the second. We want to take that times 4. Right? So the only thing we multiply is 7.24 times 4, and that gives us 28.96 times 10 to the second. but we gotta move our decimal back 1 to get it in correct scientific notation. So it's actually going to be times 10 to the third. Okay? And that's it for scientific notation.